My name is Craig Johnson. I'm a technical architect here at Forward Networks, and I want to talk to you a little bit about cloud visibility. Now, most of my career has been in data center networking. I only got involved in cloud about a year ago. Thought it was a good way to kind of advance my career and a new area to go into. So I want to share with you how I used Forward Networks to make me a better cloud engineer. And at the same time, I want to share a little story based on a real customer that we dealt with, how they used our platform to combine two different clouds together in an easy, seamless way. So in this story, there are two companies. I'm going to call them Old Money and New Money. So Old Money is a West Coast-based company. They have presence in all three clouds. So they're in AWS, they're in Azure, and they're in GCP. Mostly just around those regions there. So they're a little earlier on in the journey. They are a more traditional company. They do have some presence in these clouds as a way to have their developers burst some things out and have some presence there, but they're very early on in the journey. They're not a cloud native company by any means at all, and they're using much more traditional networking. They have a very large on-prem component. So they're doing some of that, but any separation, any security features, they're using traditional firewalls. They did a lift and shift from firewalls they know on-prem to virtualized firewalls inside the cloud. So the company they're acquiring is, we're going to call that New Money. So this is an East Coast-based company. They've only been around a few years. They were cloud native from day one. They have no on-prem component at all. All their infrastructure was done via CloudFormation or Terraform templates, completely infrastructure as code. They use 100% AWS managed services in this case. So they use different security features inside them, but they don't use anything like a Palo Alto firewall or anything like that. They use the features that the cloud providers get them. It gives them a lot more agility. So we've got some challenges. We need to merge these two companies. So let's say I'm on the Old Money company. So we know we have to do this in a really, really short time frame. What I mean by that is it's almost February. We need to have this merger done by July. So we have several different teams, and we know we need to connect these two clouds together, one from the Old Money and one from the New Money, and also to the on-prem data center component. So we have to have a merger of not just on-prem to AWS, but AWS to AWS and GCP and Azure. We can't just connect them together because in Derek's example we just talked about, we don't want to have any security posture violations. We don't want to have any security breaches. But at the same time, we want to make sure that the connectivity and all the teams can communicate with each other. Because think about it, these companies do business in very, very different ways. The Old Money, it's very traditional network engineers. Everyone's logging into CLI and consoles. New Money, it's 100% API usage. So how can we do this? So the first thing we did is me at Old Money, we decided we're going to trade our architecture diagram. I'm going to send them how we do networking. They're going to send us how I do networking. So here's what I did. I sent them my AWS architecture diagram. So as I mentioned, it is a lift and shift model. We took the Palo Alto firewalls that we have on-prem, put them inside AWS. The VPCs that we have inside AWS go through those Palo Alto firewalls for connectivity, for separation, standard zone connectivity model, just like what Derek showed you. So I said, okay, that's pretty easy. We've done this model. We know it's not the most efficient model. We know it has some bandwidth limitations. We know it's got some latency problems, but it's worked well for us. Well, at the same time, New Money sent me their architecture. They sent me this nightmare right here. So they are using something called a transit gateway, which I've read about. It's a newer way to connect different AWS zones together. But they're also using an AWS network firewall, which is really only about a year or so old. They use that to do connectivity between all of their VPCs to connect them together to give a centralized security model. So in a way, it's somewhat similar, but it doesn't, they're not logging into a CLI. They're not doing any of that. So as I mentioned on the slide before, we need to be able to, all of our teams need to be able to understand each other, work from the same set of data, and be able to work on the same info. So how can Forward Networks help with that? Well, I'm going to show you real briefly what that would look like inside the platform. So as I look on the Old Money snapshot right here, the first thing I see when I log in is the dashboard of my entire environment. So you can see right here, and let's go ahead and zoom in a little bit so that it helps a little bit. I have the Palo Alto firewalls I mentioned, traditional routers and switches, but of course I have that AWS, GCP, and Azure. Now this is the network inventory, but I also have a cloud inventory. So I can see, this is more than what you would see on-prem, I can see all of my instances in AWS, Azure, and GCP. How do I get that data? Well, all we really have to do is if I go over to my devices here, of course, I'm collecting everything that you would see on-prem, standard, SSH credentials. But inside the cloud, all I need to do is provision a very simple role based in AWS to grab that. Azure, it's a service principal. GCP, it's a number of projects. And you can easily verify that by looking inside AWS. You can see exactly what we've got there. You don't need to log into the AWS console to see this. You can see all of that data right there. Now, if I go back over here to that dashboard, I can go all the way in and I can see exactly what the instances I have there. So what I showed you before, those 5 instances I've got there, they're referenced right there. Now let's see how this network architecture would look in a combined way. Keep in mind, this is still just the old money network. If I go to the main architecture, you see all of my components laid out on a map right here. So of course, this is my on-prem component, the HQ prod network. But because I'm collecting from AWS, GCP, and Azure, it automatically sees the internet connectivity between all of them, and it automatically figures out that I have VPN connections from my on-prem network to AWS, Azure, and GCP. So if you take a look at the on-prem network here, this is going to look very similar to like what Derek showed you. You're going to see all of the different on-prem components like you would normally see. So pretty standard stuff. Pretty normal view for a network engineer. It's kind of like a Visio diagram. Of course, you can go in, you can see all the route configuration and state there. But if I go back, what would that look like inside AWS? Well, of course, AWS doesn't have physical switches or anything like that. It's an infrastructure that you're just dealing with constructs. So if I click on AWS here, you see the constructs in a much more cloud native way. So instead of saying, this is my router connecting to this, even though there are router constructs and there are firewall constructs, I see things as they would in AWS. So these are my 5 VPCs inside AWS, which corresponds to everything I have inside AWS, showing you that right there. Inside my VPCs, you'll see all of those right there as soon as that loads up. 5 VPCs that I have there. So let's look at all my resources inside those VPCs, just like I would for any cloud engineer. Open just one of those up, that internal VPC. So instead of showing you, this connected to this, I'm showing, okay, my VPC has these 2 availability zones. Inside these zones, they're connected to an internet gateway, actually a VPN gateway in this case, and the route tables that I'm associated with. So this is how it helped me learn AWS, because I can go into all these different windows inside AWS and see, but I don't quite understand how they're all connected. This is a very easy way for me to understand it. You can drill down even farther to see inside each VPC and availability zone exactly what I have down to the IPs. And we're not just looking at the network connectivity, we're looking at the security groups, we're looking at the network ACLs. So how does this help me understand AWS? Well, let's take something very simple. You saw I had an on-prem component and my AWS component. How do they connect to each other? Well, just like those path searches that Derek showed you, let's go down to the intent check here. Now I have a couple of different intent checks already created, mostly for on-prem components. Let's look at my database connectivity to AWS. So when I click on that, it's going to show me hop by hop exactly what is happening, no matter where it is in the network. So here, it starts out on my on-prem network here. You can see all of the traditional switches and firewalls that goes through the state tables, things like that. But as I keep going down, you see here, it's connecting to that Palo Alto inside AWS. So keep this in mind too. We're not just modeling the native cloud constructs, we're modeling virtualized NFV devices inside the cloud as well. So even if you were all pure AWS, you might have virtualized devices. Maybe it's a CSR, maybe it's Palo Alto, maybe it's an F5. We're modeling all of that data too. As I go out of that part there, now I see I'm inside AWS native here. So the first thing I see is instead of showing you, a state table, I'm showing you what we grabbed from AWS. Here you see, here's the cloud VPN gateway that I'm connected to. And I can actually look at the exact config of all of that info right there. You see at that next point from the cloud VPN gateway, I'm hitting a default route table, and I can see all of the routes inside that default route table and how that connects through there. At the endpoint, the subnet that I'm connected to, you see all of the different things I'm modeling inside that subnet. So it's not just routed connectivity and connections there. I'm modeling the native network ACLs, which is the way AWS does access control. I'm modeling the security groups, and I'm modeling all the way down to the exact instance.
So are you modeling all of this, or are you using like AWS network reachability, the reachability analyzer?
No, we're not using reachability analyzer. We have simply pulled the API for several EC2 compute instance APIs, and we're modeling inside our platform.
Okay.
So this is all done on platform. We're not reaching out to AWS beyond the collection.
Do you do any sort of comparison between them to show, actual state versus modeled state? Do you validate?
We don't validate with AWS because if you've actually used the reachability analyzer, it doesn't go past multiple transit gateways. It doesn't go to NFV devices. So you could use some of that. And when we talk about NQE, you could talk about how you could do some of that. But no, we don't do that. Okay. Yeah, we're using our own modeling for it.
Could I automate this with scripts maybe?
Absolutely.
To get data on regular basics?
Absolutely. This is an automatic collection. This goes out all of the time.
Okay.
So I can compare between them. I can see what's added, what's removed, what's subtracted. So absolutely.
But my other question is, are you using graphs to visualize the data or the network objects and how they are connected to each other?
Yeah. So when I X out here, you can actually see exactly how it's passed through here. So I can actually look exactly where it passes through and all the different things on-prem and as I go into AWS. So yeah, you have that visualization if you need it to.
And it's graph based. You're using graph.
Yeah, I think that's what, yeah.
Okay. Yeah, it looks like. Thank you.
So like I mentioned, I only got involved in cloud networking about a year ago. So this is pretty simple. I understand VPCs, I understand firewalls, I understand how this all connects. So that drawing I showed you before with the new money, I need to understand how their network works. So I'm going to go over to their snapshot. So their snapshot is, like I mentioned, is much simpler. They're just in AWS and of course the connection to the internet. If I go over here, I can see all of the VPCs they have there. Like I mentioned, they're using this kind of centralized inspection model that their drawing showed me, but I don't really quite understand how it all connects. So how can I use Forward to help me understand this? Well, if I go back to that dashboard, look at their inventory, they have a couple of different instances inside AWS. Let's just go ahead and look at one. When I click on that, it shows me what kind of instance it is. It's public IP address or private IP address if it has one, where it's at, any security groups. So I'm going to take something really simple. Let's just take that IP address. And I want to go from that IP address. And let's just say I want to go out to the internet. So it's going to show me the path that it takes from VPC to all of my constructs here. So you see right here, I start out in the spoke VPC. I head down to the transit gateway. I go up to an inspection VPC. I go back down to the firewall, and then I go out my egress VPC. Now, that's not the easiest thing in the world to understand because it's going through a lot of different places to keep this inspection model. But at each point, I can see exactly how it's transitioning through the network, all of the VPCs it's passing through, all of the different items. So you can see, here's my transit gateway, here's my transit gateway route tables, here's AWS network firewall, here's all of the different things that I'm passing through. Now, keep this in mind. AWS Network Firewall is about a year old. This is just one way to connect. I could use a gateway load balancer. I could use Transit Gateway Connect, to say nothing of the way Azure does it, to say nothing of the way GCP does it.
Got a quick question.
Yeah, sure, go ahead.
So you're showing all native constructs from AWS. Let's say you have something like a third-party Palo Alto firewall. You've got something else that's built in. You're doing route table controls, or you've got Aviatrix or someone else within the system. Are you able to integrate in the forwarding tables that exist within those platforms that are really third-party versus what's natively seen by AWS?
Yep, absolutely. So if you go over to that old snapshot I showed you, inside here, I have this firewall that's actually out in AWS. You see that right over here. So I'm pulling what I have in AWS. I detect that I have a firewall that's not native to AWS or GCP or Azure. I'm pulling that data in as well. So if it's an iOS CSR 1000V, if it's an F5 load balancer, we pull all that data into it. So looking at that search I just did, so this helps me understand exactly how their routing works. Because with that drawing before, I'm not that much of an AWS network. I don't fully understand it. But here I say, okay, I can see they're doing inspection to this firewall. I see their exact path throughout the entire network. So let's get back to the story. We need to merge these two networks together. Now, the most obvious place to do that is their transit gateway over here connected to our Palo Alto on-prem. So let's say we've done that. And I'm going to go over here and I'm going to show you a merge snapshot. Now, the great thing about what we do inside this type of collection, I go back over to my devices here. Of course, all my on-prem devices, that Palo Alto firewall. But inside AWS, we don't just grab what you're explicitly saying. Because we're all in an organization, everyone pays the same bills. We automatically pull all of the AWS accounts that you have inside your organization, no matter if someone adds or removes them. So you have an ability to say, hey, someone's added an account, we'll automatically detect it and pull it into the platform. And of course, any number of regions that you want to connect to, we'll pull all that data in as well. So let's say we've grabbed all of that. We still have Azure and GCP and all of that data right there. Going back to the main page, actually, let's go to the dashboard. So you see how all of that data right there. Now, if I look at my inventory here, I have a combined list of both instances from both sides of the network. And I actually break it out because you see right here, I have the different, this one's a little cut off there, but I have the two different accounts that I'm connected to so I can see these two right here. Go ahead, move that. Are from this account, and all of these are from the other account. So I see all of that data in one place. So let's see, how would I use this data to troubleshoot connectivity between these two? Like I said, all I did was connect both VPCs together via the transit gateway. Let's go back to the main page. And now you can see I have my AWS West, but I have a link right here between my prod environment and the new money. So old money and new money are connected here. So the issue I'm having is they don't connect to each other. I'm having security issues. There's a connectivity problem. So we've got two different teams, but here they all have the same access to the same data that they can use. So let's use that same intent check to see how we would troubleshoot that. I go over here. So I can validate what I had already still works. My database to AWS. This is on the old money network. That still functions, so I can validate that. But if I look over here, here is my new money to old money. So if I mouse over that, it says, okay, that IP address from the new money network connecting to the one to the old money, that shows up as failed. So this is just someone doing a path search saying, I want to get to an instance from new money to old money. Well, it shows up, says I put in delivered, shows no results found. Well, let's troubleshoot this a little bit. Removed the delivered right there. Now it's going to show me the path. So I already validated the path from the new money network going through the AWS network firewall. Scroll all the way down to the end. It goes to my virtualized Palo Alto. You can see this is the point that it drops the traffic because I'm missing a zone rule here. So now I've used this information to quickly nail down exactly where the problem is in the network. Both sides have the same data, and they have it in a way that makes sense to them. The cloud native teams see cloud native constructs. The network teams see standard network diagrams and routers and switches. Now, I've only really scratched the surface here. If I look over and what else I see inside cloud networking, AWS does things slightly differently than Azure, does things slightly differently than GCP. They all accomplish the same goals, and they come out with new features and new products all of the time. Because we natively understand all of that data, like I said, it could be a gateway load balancer, it could be a connect, it could be an Azure route server, it could be GCP network connectivity center. We have all of that information. We give it to you all in one place. In this story I told you, we use this to solve a very simple problem, and we're able to make that merger done very, very quickly. This is how it helped me become a better cloud engineer. Like I mentioned, I only got started about a year ago.
This is great when you're using native constructs natively. This is great when you're looking at, networks that are built in traditional ways. But so many of the networks that I'm working on now deal with underlays and overlays. And I guess I'm kind of curious, is that taken into account in the modeling in forward networks? Do we see the impact of a change on an underlay on what it could do to the overlay?
Yeah, of course. So if I look over on that intent tech I showed you before, I didn't highlight it so much, but it's showing me this is how it passes over MPLS. These are the labels that get pushed and popped. That works for VXLAN, that works for native tunnels. This is actually a GRE tunnel, actually an IPv4 IPsec tunnel going out in AWS. So whether it's underlay or overlay, we're looking at the data plane, we're looking at the forwarding table, so we know exactly the impact.
I'm talking more about like on net or where I'm running the underlay and overlay. So SD-WAN as an example, or you were talking cloud. I'm thinking specifically, there's some products out there that I work with that are cloud networking overlays. They're meant to simplify the native constructs, kind of give a consistent experience, whether you're using, Azure or AWS or whatever. If you're using one of those, if you're just looking at the data path, it's just the gateways. All you're seeing is the overlay. Are you able to correlate what happens in the underlay? If I make a change into an AWS native construct, does that change, the pathing between two of my gateways? Are you able to correlate that information? It's a really difficult question, and I understand that. No, I just want to understand where this ends.
Yeah, absolutely. So if you were doing something like NSX in the cloud, we would collect from NSX and collect from AWS, and we would see the paths that, okay, here's the NSX tunnel from this point to this point. It correlates to the underlay right here. So any point you can actually look at what the underlay looks like. So we're collecting from all of the data. Same with SD-WAN. We support a number of SD-WAN vendors. If they're connecting into like a direct connect gateway, we'll see exactly where it is. And we can look at the underlay that's up. So you can see, okay, this is a tunnel between these two, but it actually goes through these parts right here.
Do you support this level of visibility with a Kubernetes cluster?
So we do see the Kubernetes. That's something that we're doing right now to be able to go into each one of the pods and look at the service sets and look at the service IPs. We see them as endpoints and we can go there. I'm not going to lie though, it's something we're not to that level of detail yet though.
How do you deal with state when you're not, when you guys are looking at, I guess kind of a predictable ideal state where everything functions as expected, but in the world of, when you have a mix of cloud and on-prem and you have network gear that might have bugs, have you guys thought about that problem at all? That, hey, I have this known bug that if I put this piece of config in, I'm going to get a state that isn't expected. Is there a way to capture that, or is that too far out yet?
No, it's not too far out. Like we're looking at what the device is telling us where it goes to. But if there is, like you mentioned, that there's something that's going on the interface or something like that, that is an area that we're going. So right now we already look at, I think Derek covered it, where we can actually look at known CVEs, known issues on those devices and see how it impacts.
I think the question might have been a little different.
Okay, sure.
As opposed to CVEs, but more hardware bugs that are encountered in reality on that one device.
Yeah, that's really,
happening. So we can't see those because we're modeling. But we have offline models. Effectively, we have racks and racks of gear where we're trying to find that The behavior in reality should match the model we show at all times.
Yes.
That's a huge focus of the company. Now, where that doesn't give you accuracy is for those one-off, this one device has a transceiver that's going a little weird, or the forwarding table isn't doing what the device is telling us. To some degree, we have to depend on what that device is telling us. But we test that if a device tells us something, that we're going to model it as accurately as possible, whether it's on the cloud or whether it's on-prem.
Right. And that was really the origin of my question. I know that's
I
an
see.
incredibly hard problem to solve, because if the forwarding database doesn't go where the routing table thinks it should go, that, it's a bug or whatever. I was just, that is something engineers have to deal with. And I was just curious if it's even on your radar as a problem to solve.
So in terms of like correlating the routing database to the forwarding database, that is on our radar, be able to show you, okay, this is what BGP is telling me what the network looks like versus what the actual FIB is forwarding. We can,
Right,
that is on our radar, yes.
Okay, that's cool.
Now getting down to like the ASIC, does the ASIC program correctly? We're not quite to that level though.
Got it. Okay.
On the cloud side of things, are you also modeling down to security, like network security groups or security groups on instances as well?
Yeah, absolutely. So if you go to this one I showed you right here, I can see the security group. I can see the exact security group. This one is allowing 22 on there. So it's telling me the security group all the way down to that. So absolutely.